Hi, everyone. I'm Katie from Hackster. Welcome to ElephantEdge webinar with Smart Parks, Edge Impulse, and SoftWeb Solutions. We've got Tim Van Dam, Zach Shelby, and Vibhu Bhutani here with us to share a little bit about the ElephantEdge Challenge and how you can get started setting up the software for your project builds. So Tim Van Dam is a co-founder of Smart Parks. He's a senior business developer in the telecom market and expert on LoRaWAN technology and other sensor networks. He co-founded Smart Parks to turn the latest innovation technology into solutions for protection of wildlife, visiting and working in protected areas across Africa, India, Europe, and the US for the past 20 years. He has a clear vision on what is needed in the front line of wildlife conservation. Zach Shelby is the founder and CEO of Edge Impulse. He's an entrepreneur, investor, and technologist in the embedded space with a passion for tiny ML and internet engineering. Zach is a former ARM VP, founder and CEO of the Microbit Foundation and Sensinode, active in several of his portfolio companies and secretly working to bring ML to any embedded device. Vibhu Bhutani is a chief strategy officer at SoftWeb Solutions, Inc., an Avnet company. He has been with SoftWeb Solutions for the past 10 plus years, and as part of his role, he manages the formulation and execution of business strategy and leads both the IoT and AI teams. With his combination of technical and business skills, Vibhu paves the path for product development for the core IoTConnect platform and its surrounding ecosystem. Today, we're going to have about 50 minutes of presentation and then 10 minutes at the end for a Q&A. So if you do have questions today, you'll find a Q&A little icon at the bottom of your screen. You can click on that and post your questions there. We'll try to get to them throughout the event. Zach, Vibhu, and Tim will be answering questions via text throughout the event, and then we'll also have another 10 minutes at the end. We'll be answering some questions live. So thanks for joining us today, and I'm going to let Tim take it from here.
Thank you so much. Yeah, thanks everybody for joining. I'm Tim from Smart Parks, and yeah, this is really a webinar about ElephantEdge. As you can see on the screen, we have started to build together with you and all the partners to start building the most advanced wildlife tracker for elephants, together with Smart Parks, Hackster, Edge Impulse, Microsoft, Western Digital, Nordic, Tauglass, uBlocks, WWF, EarthRanger, and Avnet. And yeah, it's first of all about, I want to talk a little bit about the why. So, okay, so it's about protecting the elephant, and actually there are two elephant species. There's an African elephant, which is obviously living mainly in Africa, and it's very vulnerable at the moment, as you can see. I can talk a little bit about the threats, but we all know there's been some heavy poaching over the years, but increasingly there's also issues with threats from getting into all the areas where the elephants live and has been living for many years, and this is mainly caused by human behavior. Well, these are some of the threats you can clearly see, and there's another population, which is the Asian elephant, which is actually officially more endangered, and is living on the Asian continent. And this is actually more threats coming from not so much poaching, but it's more like human-wildlife conflict, as we call it. So more and more people are taking up land, which is normally, which has been normally used by the elephants. So the elephants go into areas where people use the land for farming, and yeah, you can have these real high conflict areas. So you can actually see here some kind of the images that also reflect that there is a big issue with climate change, of course, which is causing droughts. This is mainly in the African continent, but also on the right you can see these horrible pictures about human-wildlife conflicts and where it really hurts. So this is actually why we do this contest, to use technology to prevent this this kind of trauma. And we are from Smart Parks, and this is our mission. We are actually here to protect wildlife with our passion for animals and wildlife, by using technology. We are a non-for-profit based in the Netherlands, and we are active all over the world by helping to deploy these technologies. And this is a short movie about how we are using technology, and it explains a bit what a smart parks is in our perception, and also gives a good environment where we are going to develop this elephant tracker. So you have a little bit more understanding about what technology we're aiming at. So as you can see here in this video, we are using wide area networks, IoT networks, to actually get information from all kinds of assets, animals, movements, weather, all kinds of sensor information from these protected areas to allow park management, people that are there to protect these areas together with the community and the rangers, to make better decisions, sometimes in real time, but also sometimes based on the data, you can do analysis and come up with new long-term solutions. So it's really about gathering more information and creating what we call situational awareness. So the rangers, the communities are more aware of the area which they are protecting. And of course, then it's very important if you can also protect or monitor the animals that you are trying to protect. So of course, then you need some kind of a network infrastructure. And we have been building quite some infrastructures all around Africa, even in India and Mexico, and also in the Netherlands. But what we also see is that people really get this technology now, so they are starting to build networks themselves. And for example, even with community networks like the Things Network, you can actually see that all over the world there is network connectivity that is relatively easy and cheap to use, even for these type of applications. So that's really, really cool. So if you want to build an infrastructure, of course, you have to do some work, and here are some pictures about building towers, setting up operational rooms where you can actually see the data. So this is the work we are doing to prepare all these parks to actually use or put in sensors that can actually generate the data. A little example about the front-end application we are using, but here you can see in a park in the Netherlands, actually, where we have protected wisents, which have been brought back to the Netherlands and are protected. And here you can see long-term movement patterns of these animals, which help to understand where these animals are. And also, if you want to protect them, you can easily find different patterns if they are disturbed. A little bit about how technology works in this process. So here you see a simplified model where you can see there's all kinds of data being collected, even video data, but also sensor data. This is where we are mainly at. And all in the end, you can see that there's more development into smart sensing, artificial intelligence, tiny ML, and this is of course where Edge Impulse is coming in, and we are really trying to bring those worlds together. So the real high-tech, tiny ML, we really would like to see that happening on the sensors, so we can actually have more intelligent information going further in the flow, where you analyze the data in real time and combine that with the historic data and get actual to threat alerts, so you can dispatch your armed forces and react upon it. While we were building this network, we found out that the sensors are not actually ready to generate all these data, especially not on the animals. So we started this Open Color initiative, which was launched on the Things conference, I think 2 years ago already. And we really started with developing the world's smallest, most high-tech sensor based on LoRaWAN, which is actually the Rhino sensor, very small. And then we moved also from the other end where you have, let's say, a big platform, which is the elephant, which is the biggest land mammal, where we can really go, well, use the space we have there to bring all these advanced features. And now we are actually bridging the gap between. So we also have lion collars and everything between. So cheetah, wild dog, giraffe, pangolins. So yeah, it's really moving from two sides. Everything is open source. And yeah, this challenge is about how can we even make it better and add all these great capabilities with all these great partners. And just to give you an example of where we were 25 years by this great person, Ian Douglas Hamilton from Save the Elephants. And he was one of the first that started with collaring elephants. And here you can see, yeah, what he was doing back then.
Trying out an experiment. Although GPS seems ideally suited for tracking elephants, it'll require the world's biggest radio collar.
The collar is made of double layers of machine belting, which are stuck together with a strong glue. And it has double washered rivets the whole way up and down. Experience has shown us that it gets extremely hard wear from the elephants. It gets rubbed and smashed against rocks and rubbed against trees with tons of pressure behind it. At the bottom, stuck in a block of acrylic, is a conventional radio transmitter. There's also some batteries, and the cable goes up the spine of the collar all the way to the place where the GPS is going to sit up here, pointing up towards the satellites so it can receive the signals.
So actually not so much has changed other than that we found out that well, this system was still in place. So the existing tracking companies were using the same kind of collars, the same kind of satellite technology, which was to us like, well, these collars are super huge, they're very heavy, and they're, well, just giving positions of the animals over satellite connections, which is very cool, of course, that we can do this. But I really believe we can do so much more, even knowing that all the sensors that are available these days, and we can do it with way less power. So we can even shrink the whole collar down, so it's less of a burden. We can make it cheaper. So this is what we started to do. So the first elephant collar is already there, actually, the open elephant collar, as you can see on the picture. So most of the engineering on the, let's say, on the physical part is done. We know the belting is working. We are using very good biotane belting from the US, which is also quite light, but very strong. We have very nice enclosures, which we can adapt it, but they are strong enough. They are very nice, so they can actually house all these new technology we want. So this is, I think, important information. Another notion I want to give is that when you are going to collar an elephant, it's not an easy task, and the technology is not the only thing that matters. So you can actually see in this picture that was taken a couple of weeks ago while they were collaring an elephant in Malawi. You can see how many people are involved, well, doing putting a collar on a bull. So I think it's good to understand that it's, yeah, the whole process involves more than only just the collar. And also, if you are putting a collar on, you need to make sure it works really well, and you actually get all the information from that collar that you want. And we are really aiming for 8-10 year plus duration. And I think we can even do better, but of course, then you need more batteries. So I think going for a device that can be used for 8 or 10 years is already a big improvement. And I think that even then we can use all those tiny ML capabilities to get more, yeah, good information from that color. So we were at Elephant GPS in 2019, so and then we were going now to the ElephantEdge, which will have all these new features like Bluetooth beaconing. It will have an app connectivity. It should be able to sniff poachers maybe by their phone, or use acoustic detection, VHF beaconing, and maybe even OpenMV camera options, so we can even do fancy stuff with heat patterns. Yeah, so I think the world is very, very cool at the moment, and we can really put this technology to work and deploy these collars into these protected areas. So as you can see also on the campaign website, I've listed some of the use cases I think that are sensible, knowing that what kind of sensors we are aiming for. And one of the things is poach risk monitoring, meaning can we make mechanisms that make this model, so the hardware and the software combined, intelligent enough that it really detects when an elephant goes into high poaching risk areas or behavior. We can use all kinds of sensors that are on board. Human conflict monitoring, I think it's very important, especially for the Indian elephant, where we can try to find out if the elephants get close to human population, where they are essentially immediately at risk. And I think there's much we can do there, which is not yet there, which is not only about location tracking, but maybe also about using the Bluetooth or other sensors to detect human presence. There's this funny behavior of elephants going into mush. So mush monitoring, which is what bulls do even now and then, and they go into in the spirit of a condition where they have high aggressive behavior, and you can even see it on their faces, where you can see the fluid coming off their faces. And they probably make acoustic notions that we can detect. So I think this is also very interesting, because this is a period where the elephant is quite dangerous, especially when it comes close to humans. So this is interesting. I think we can use all the sensors to detect this. Activity monitoring is a little bit more straightforward, and I think there is also really a low-hanging fruit for TinyML and Edge Impulse, where we can use existing knowledge we have about elephant behavior, about movement patterns, to really automate the detection based on accelerometer data, which is pretty straightforward, but of course needs to be trained in the right way. And based on what we can do with Edge Impulse, I think this is really, really valuable if we can put it back into the collar. Elephant communication monitoring, I think it's super cool that that we actually know now that elephants communicate in all kinds of way, and they use a lot of sound. So I think that's also very interesting. We can deploy that into the collar. And this is a very short video from Hidden Vocals, Elephant Listening Project, which is great. And they actually recorded these sounds with special microphones, and you can actually see, you cannot hear it, but you can see the elephants communicate. So this is in a directional microphone pointed at the elephants, and you can see in the graph actually the patterns of the vocals. So imagine if you have a collar on each of these animals, and you can actually track that vocals without pointing a microphone at it, just always whenever you want it. So you can turn that feature on remotely, and you will be able to detect certain communication patterns and relay that back over LoRaWAN or any connectivity to the control room to detect threats or behavior. So to finish this off, be kind, connect, act now, a slogan. And yeah, I just want to say that the technology can really help to save the planet, but yeah, there's obviously more to do. But I think we can all try to help the people in the field, as we call it, to make their life a bit easier. And, yeah, put technology at work. So over to Zach.
Thank you, Tim. That was really inspiring. And for us technologists, engineers, it's great to think and really understand the why and the applications that we can work on. And we want everybody in this competition to be creative, right? This is not about us telling you how to solve these problems and even what combinations of problems can be solved with these sensors. We're really looking to you to, inspire us with what you come up with and new ways of combining these things, and help us prototype and be proof of concepts around these applications. They don't have to be perfect, but they have to give us the ideas, right, of what's possible and what the technology can do. And then we'll take it from there. We'll work with the winners to go and productize these algorithms in practice. So I'm going to talk to you more about machine learning, and in particular, machine learning on these small battery-powered microcontrollers, which is what powers these types of wildlife tracking collars these days. Now, in this particular project, we have a Nordic NRF52 part, which is really widely used, well understood microcontroller platform. It's a general purpose Cortex M4 microcontroller with enough flash and RAM for us to go and do not just the communications, so the LoRaWAN that Tim was talking about, but also we can use the math capabilities of these microcontrollers to do the number crunching and the signal processing and even the neural networks required to match pretty complicated patterns. And this is a very new field, right? We've all heard about machine learning for the cloud. What we've been doing at Edge Impulse is optimizing what machine learning means for the very edge, these battery-powered embedded devices, and providing the tooling to make this available for all developers, and including all of you in the ElephantEdge competition. So you'll be able to use the tooling that I'm going to be teaching you more about now. We'll dive in with some practical exercises. I'll show you some examples of how things work. And we also have support for you. So we've got some really good support documentation, as well as support forums where we'll be helping you out as you make progress on your project. So don't be afraid to ask if you have some problems or have some questions. Now, a really important thing to think about and understand when it comes to machine learning algorithms is that they're different than software, right? Machine learning is data-driven, whereas software is code-driven, right? Like you as a programmer are writing lines of code which create rules and some algorithms. And the typical development process for you as a programmer may take some months of writing code, testing it, improving it a little bit, testing it again. And that's your development cycle for software coding. Machine learning works differently in that the entire process is data-driven. So the purpose of machine learning is to use data to drive algorithm design or drive the algorithm tuning, right? So instead of writing code, tweaking the code, testing, improving, tweaking, we collect data. We do a good job of labeling that data, right? Identifying what happened at this time, right? What signals are important? What are the things that we want to detect? And then using that data set to train different types of algorithms. That's where the machine learning comes in, right? We're training the algorithm to learn the pattern that's in the data. And then we go and do some testing on that algorithm. We'll try it out. We'll try it out on some new samples that haven't been used for training. We'll see that it works in some cases. It doesn't work in other cases. We try to visualize for you where you might be missing data points. And then you go back and collect some more data. Fill in your data set, right? Improve your data set. Maybe add some category labels that you didn't have before. And then you continue. So the process in machine learning is all about data and data set improvement, and then tweaking some of the algorithm parameters and testing. And so at Edge Impulse, what we're doing is providing you a cloud-based platform to go through this entire process. It starts with the actual sensors. So it's important that you're collecting data from sensors that are relevant. Now, luckily here, when we're working with wildlife trackers, we're using things like accelerometers, very common, and we're using audio. And we might use some images, and I'll talk a little bit more about image-based ML. And that's an optional thing, right? We might put image detectors on some collars for special projects, right? And all of these sensors, luckily, are found in your mobile phone, right? Each of you has a mobile phone, probably a smartphone, and you'll have these sensors available in your phone as well. And so we've developed mobile phone support in Edge Impulse for data collection. And so for some of you, when you want to prototype your projects, you can use a mobile phone to collect sounds and to collect accelerometer data that you can use to prototype your application. So we'll talk a little bit about using the mobile phone as a sensor. We also support embedded platforms directly in Edge Impulse. And we do that to make sure that you can collect sensor data directly from the sensors that you might be using in your application into the platform, your data set. So this is an Arduino Nano BLE Sense, really, really common, cheap development board. We support this out of the box. It's got 3-axis accelerometers and audio, both. And we can stream sensor data directly from the Arduino Nano BLE Sense into your data set, and you can work with that. We can also deploy algorithms back to the embedded device. So when you've gone through your development cycle, in the end, we deploy a very, very small, what we call an inference library. It's the library that you put raw data into, and you get a probability of a certain class or an anomaly out. And so raw data in, answer out. We integrate that model into the embedded device. And we have an option to build it automatically and deploy it on this device and many others. Or you can also deploy it back to your mobile phone. So you can also test your algorithm on a mobile phone. And so don't be scared to improvise and be inventive when it comes to data, right? We do not expect you to have access to all the perfect elephant data from the field, right? That's impossible for you. We have data sets that are available where there are elephant vocalizations, right? There are elephant movements, elephant images, and please do use those data sets, right? Be creative in how you use them. But where you don't have a data set, make one, right? Act like the elephant with your mobile phone and your neck if you need to, right? To try to give an idea of what these movements are, right? And make use of elephant sounds that you can get from recordings. Record those with your mobile phone if you need to. Get them in a data set. So be really creative about how you're putting together a data set, because it's the concept that's more important than the actual data implementation. We'll go and get proper data from the field for a particular type of movement or activity and improve your idea when we get to production. So we start with data. You build that into a data set. We're then going to take that data set and use that to train algorithms. Now, in Edge Impulse, we don't expect you to build algorithms from scratch. You certainly can, but we have libraries of existing algorithms that are really useful for these types of applications. And today I'm going to demonstrate two types of projects. One is an accelerometer motion detection project. So we talked about elephant activity detection. We'll show you some examples of human activity detection and how that works. And audio detection. So I have a couple different projects with some complex audio and how you detect patterns in audio. So we'll look at those two different types of projects hands-on. We also have the ability to work with images and image detection with the OpenMV platform, and you're welcome to use that as well if that's something that you have interest in and you want to work on image detection. But remember, it's going to be from caller, right? So what kind of images, what kind of things would be interesting from caller is it's an area that really hasn't been done before. So it's wide open for exploration, what kind of images could be interesting from the elephant's point of view. Once you've chosen those algorithms in our platform, we automate that process of training the algorithms with a data set. And then once you've trained your algorithms, we give you some initial results based on the training set, but we also have some nice tools for testing. So I'll run you through how testing works. And then finally, we automate the process of building that model for your target. And again, you don't have to run these algorithms on an embedded target if you don't have one. We'd love you to try it on embedded, right? Let's make sure it's kind of small enough and efficient enough that it could work on an embedded target. But if you have a mobile phone, feel free to use that as your deployment target. We support that in the platform. But I'd love you to try this out on a microcontroller. If you have your own microcontroller that we don't support out of the box, don't worry. We also support C++ code output as source code. You can build that C++ code into just about anything. Cortex-M, Cortex-A, and other platforms as well, ESP32 as well. So feel free to also get inventive with integrating this in your own embedded hardware if that's something that you're able to do. So I'm going to run us through this process, and in Edge Impulse, it works step by step, right? So we walk you through the process every step of the way, from working with your devices and adding them to your project, acquiring data, designing, right, on a block-based graphical way, training, testing, and deployment. And I'm not going to spend any more time on slides. I'm actually just going to walk you right through how this works. So getting an account, if you don't already have one at Edge Impulse, is really easy. We have made the platform free for all developers. So getting access to the platform doesn't need any special permission. You don't have to be part of the ElephantEdge project. You simply go to edgeimpulse.com, hit login. Login will ask you just for your name and your email address. That's it. We don't collect any other information. You don't even have to give your last name. You'll get an email with activation, but really you can just log in right away with your password and get started. When you get started with Edge Impulse, it will bring you to what we call a dashboard. And sorry, let me get to the right project. It will bring you to the dashboard here, where you'll work with your project. And every project in Edge Impulse, you can create multiple, is one ML algorithm chain. So for example, I have a project for continuous gestures. These are human gestures, but they're not all that different from elephant gestures, right? Or elephant motions or activities. So the continuous gesture project here is one that we put together ourselves. We've done this with our own team just by collecting motions of different types into the system. Some of the data has come from mobile phones. Some of the data has come from several different embedded targets. So you can mix and match embedded sensor data and mobile sensor data. It's not a problem. Just remember to get your axes right? Be consistent with what's the z-axis and what's the x-axis, so you have a similar motion that you see. The first step of the process is connecting a device. So by far the easiest thing to do is to start with your mobile phone. And connecting your mobile phone is really simple. We have a connect to device button. You click that, and that will give you instructions for different types of devices. So it'll list the development boards that we support for you, but it will also let you get started with your mobile phone or even import a pre-built data set. And so this continuous gesture data set we do have available here, pre-built. You can just go and import this with these instructions. It's pretty easy to do if you want to get started with something that exists. But we make it really easy to start with your own data. So I would really encourage you to start collecting your own data samples or your own motions as a first project. So we're going to do that with mobile phone, and I can connect my mobile phone here to this project simply by clicking this button. It generates a QR code. I'm sure most of you are familiar with this. You just point your camera to this QR code. It will give you a button for, and I'm playing with my phone here right now. It gives me a button for opening my browser. And we then open a web app in the browser on your phone. We're basically running an Edge Impulse application in your phone. You don't have to install any app. It's purely a web browser-based solution. And this now connects. It gives me a message that says, my phone is now connected to Edge Impulse. So now I have an active sensor device that's connected. And you can do this with groups, right? You can connect multiple phones to the same project as a group and collect data together. There's no limitation on the number of devices. So I now have a mobile phone connected here, so I can start working with my project. When I show you the audio project, I'll show you how to connect this device. The first step then is data acquisition. And here in this project, I already have some data. I have 16 minutes of different accelerometer-based motions. And the way this works with machine learning is these are samples. Each of these samples is several seconds long, but a sample could be anywhere from a second to minutes long, depending on the type of data that you're showing. What's important is that one sample is one type of label, right? You don't want to mix and match them because this is how your algorithms learn. So in these cases, these are up and down movements. So moving my phone like this. We can also do very complex things. Like this is a fist bump movement. We've done this as part of a COVID project where we're trying to tell if somebody's doing a fist bump or if they're shaking hands, right? And try to give them some warnings. We've even done things like drinking water. So I can put my phone like this next to my water glass here, and we can detect when someone is drinking a glass of water simply from that movement. So you can detect really, really, really complex motions and different types of motions with these types of algorithms. You can add new data to this project really easily. So we have a live data recording feature here. So I just refresh my browser, my phone shows up here. I can collect a new sample into the system simply by hitting start sampling. And then so I have to give access to the accelerometer. We take security there. I'm going to move my phone up and down. And voila, we have a new sample now directly into the system. So adding to your data set's a pretty interactive, simple process. We do have tooling for getting data into the system in other ways. So if you go into our documentation, it is very, very complete. We give you, instructions on how to do things like forward data over a serial interface, a very simple protocol, just CSVs, and forward that to the cloud if you have an existing sensor platform you want to use. And we also have a tool here for uploading files to the system. So if you have existing files like WAV files, images that you want to upload, you can go to the upload CLI and that will show you how to do that. So you don't have to record live data like this. You can import data that you have from other sources. So you could mix and match, for example, elephant data sets that you find from the public internet or from our pointers with your own data sets. So once we have some data, and it doesn't require a huge amount, here I have over 10 minutes, 20 minutes, you can already start testing algorithms with a few minutes of data, including audio. So start small and then work your way up from there as you improve your algorithm. We have different sets of algorithms for different types of applications, and you'll find this from our tutorials on each type. We have a tutorial for continuous gestures. You find that from documentation. We also have a tutorial for the audio applications. And it will set you up with the different types of blocks that you need to do this application. In the case of continuous gestures, we're using something called spectral analysis. It's signal processing to extract the stuff that's important from time series signals. And then we pair that with neural networks and classical machine learning for anomaly detection. So each of those in the system shows up as a block. You don't have to code the machine learning, you just choose it from our library. And you can change these at any time. We have library options for different types of things like audio or images. Or if you want, and if you do have something special you want to do, you can even plug in a custom algorithm here, if that's something that you're capable of. Once we have this chain of signal processing, we can go and train the network. And so we have an automated system here. We'll go to our neural network where we can train this algorithm. And I'm not going to do it here. I've already pre-built this for you just for time, but simply by hitting start training here, this will train the neural network classifier with your data. And what this does is it trains the neural network to detect these different types of labels that you have in your data set. So I have drink, fist bump, idle, snaking motions, up, down, and waving. And this tests how good my algorithm is at telling the difference between these. Now this data set's pretty small, so it shows that I have 100% accuracy. That's not quite true. The accuracy will be more like 90-some%. And this shows my, very important, my on-device performance for Cortex-M4. So this is really important to look at while you're doing this and you're choosing algorithms or improving them, is that you want to be within a reasonable amount of resources on the device. So this is for 2 seconds of data. I don't want to be more than 2 seconds of inference time because that takes battery power. So try to keep your inference time and your memory and RAM usage at a reasonable level, hundreds of K of flash and RAM max, and try to stay real time in your inference time if you can. Once we've done that, we have a machine learning solution that's ready to be tested. And we have a live testing capability here where you can live test your algorithm right from your device. And this is important because you want to be able to test while you're working, is this working or not? And so again, I'm gonna refresh my mobile phone here. The mobile, when your browser times out, it disappears. You just hit refresh and it shows up again. So I refreshed my mobile phone, and now what I can do is instead of streaming data into my data set, I'll stream data for testing purposes. It never goes into the data set. This is purely a test. And I can start sampling here, and I'll do another up-down movement like we did in the data set side. And this will live classify. It'll test our algorithm in the cloud and visualize for you what happened here. So this successfully detected 11 up-downs. That's true. We did up-downs here. And it graphically shows you why. So we have a lot of explainable ML here. It will show you where this data is in relation to your training data visually. So you can pretty easily debug what's happening. And I'll show you another example here where instead of doing a known movement, like up-down, I'm going to do just some crazy shaking. Some elephant shaking here. And this is something that the algorithm hasn't seen before. So this is a very violent movement. I've got some side-to-side movement there too. And we have an anomaly detection algorithm here. That's that other block that we have in the algorithm that detects when something's abnormal, right? And that's important because the machine learning network thinks this is up-down, which is not too wrong, right? It's the closest thing it knows. But if I look at the data here, right, this data is way outside the space of anything we've seen before. And so it really is an up-down, right? This would be a new class if we wanted. But our anomaly detection picks this up, and that's important. It's important to use anomaly detection together with neural networks so you can tell when something isn't quite right in your data. Or you have to have data classes that picks up the noise or the anomalies. So this live testing feature is really important as you're developing your algorithm and improving it. And then finally, to deploy down and test on your device is pretty simple. If I want to test this on my mobile phone, I don't even need to go here. On the mobile phone app, we have a button here that says switch to testing mode or switch to a classification mode. And by clicking this button, this will automatically build the project, download it on your browser, and you can start testing this right away on browser, on your phone, standalone. It doesn't even need an internet connection once it's running. So that's one way to test your algorithm all the time on your mobile phone, but you can also deploy this to device. And like I said, you can do that as a C++ library, pretty easy to integrate at anything. We can do an Arduino library out of the box. Or if you want to test this really quickly on one of these embedded platforms, you can just build a binary image for an Arduino Nano BLE. And it's just drag and drop, right? Put this on the device, open your serial port to the device, and you'll be able to see the inference running on device. So you've got a bunch of options. And here, I'll just show you quickly now, this mobile phone sampling is running. And so every 2 seconds, it's sampling the accelerometers and telling me what the probability is of an activity. So that's how you use this type of technology for activity detection with accelerometers. It doesn't really matter what the sensors are, right? From a machine learning point of view, we don't care what these signals are. They're just numbers, right? So you could exchange accelerometers for magnetometers, for gyroscopes, for temperature, for color, you name it, right? As long as it's a time series signal, we can work with it in EdgeImpulse. Now, the other type of project that you're going to come across is audio. I have a couple different projects here. I'm going to show you the cough project because I suspect that you've got similar types of sounds coming from elephants when they're vibrating their vocal cords or their sounds, right? When they're vocalizing, you're going to see similar types of patterns. They're going to be short. They're going to be continuous for a short time, and you're going to want to detect that. So I'll show you what this Arduino cough project looks like. Now we have a blog about this. This is something we did for a COVID challenge on detecting COVID coughs. You can find this blog on our website or on the Hackster site, and this will walk you through step-by-step how to do this yourself. The process is very similar, right? Instead of collecting accelerometer data, when we collect data, and now I've got this Arduino Nano BLE Sense hooked up live here. We do that by running a command line tool that communicates over serial with the board and connects to the cloud. We have really good instructions on how to do that. I've collected all these data samples for this project using the Arduino Nano BLE Sense. And instead of being accelerometer data, each of these samples is an audio file. Think of it as a file. It's a short audio signal, usually 1, 2, 3 seconds long. But if you have continuous sounds, like for example, some of this coughing can last a long time. We even have 1 minute long samples. The important thing is though, each sample has to be the same sound, right? You can't mix and match. So I can only have a cough sample here if every cough fills in a window of my data. We've got some nice tools as well for things like, I can show you here. If we wanted to split this, we have tools for things like splitting samples. So we can split this into smaller samples. So if we have like a cough every 5 minutes, we can change that. So same process, but with audio, you can build the same kinds of models. And I'm going to hand over to Vibhu.
All right, thanks, Zach. So I'll just jump directly into the IoTConnect demo. We just have around 11 minutes to do a quick demo around it. Just to give a background, IoTConnect is an IoT and AI platform built on Azure infrastructure. So most of the IoTConnect that we deploy, it's been deployed on Azure. From an IoTConnect standpoint, today I'll just walk you through quickly about how to get access. So again, from an ElephantEdge Hackster page, we can see that you can get access via a quick email to ElephantEdge@IoTConnect.io, and we will send some access credential shortly. We have said 2 business days, but pretty much it's pretty quick to send access to the platform. Now altogether, it's an enterprise platform. With regards to enabling your devices and connecting your devices, sending real-time telemetry data, and then build dashboards on top of it, and then of course export your data to certain different application. Could be EdgeImpulse in this case, or it could be any dashboarding applications that you might be familiar with using, either Power BI or any other tool that's pretty much out there. You can take the data from the platform and integrate it with that tool pretty quickly, and then build your dashboards over there. Quickly running through, once you log in with your account, of course, once you have access to the account and once you log into the account, this is kind of a pretty straightforward dashboard that you will see. You'll be able to see how much device to D2C messages were sent, so device to cloud messages were sent, how many commands were triggered, and so on. Most importantly, you'll be able to see what plan you are on. And again, if there is any reason that you're not able to connect it, if you have exceeded the quota for some reason, you might be testing and done some exceeding the quota of that, feel free to reach out to the discussion board, and we'll be able to help over there. But basically, you will see your plan pretty much expires, I believe, from in a 3-month window. So we have a 3-month free plan for the Edge Impulse users to begin with. Now, with regards to how to use the platform, firstly, I'll show about some of the device SDKs flavors that we support. So one of these SDKs you can directly put into your device. We provide various levels of SDKs into the platform. Pretty much, in this case, it might be a C SDK that might go in, or if you are using Raspberry Pis, as I have seen a couple of questions surrounding to that in the chat window, then of course you can use any of the Python, Node, or Java SDKs. And if you plan to use your mobile phone for simulation of certain purposes, then of course you can use the iOS or Android SDKs as well. So we cover a lot of device using these SDKs. But for some reason, if the device SDK doesn't works, then of course you can build your own. I believe it would be too much to ask for in this time frame. But we just wanted to give you an example that you have 6 to 7 different types of SDKs that you can use, and if any of these doesn't fit for any specific reason, you can build your own SDK. Just do some calls to the cloud, and you can just use the direct SDKs into the platform. Going back to the resource section, you can also see the developer APIs, and from a developer API standpoint, I'm sorry, the login expired, but from a developer API standpoint, you'll be able to see all the APIs that you can use, and provide more details to your dashboarding solutions. Digging deeper into the devices sections. So once you have your hands on the SDKs to be used, what devices you're planning to use, it could be either a device or a gateway device. Again, if it's a Raspberry Pi or some of these devices that you are exploring with, you will be able to add a gateway device to the platform. So just showing the devices. So once you go to your devices, one key thing to use in the platform is the templating mechanism. What it allows you to do is define what the data would your device send right here in the cloud. When I say defining, it means that you can say that okay, with your attributes, we'll have all of these different attributes that your device will send to the cloud. It could be, so you can create multiple templates surrounding to that, but this template defines so in this case it could be a temperature sensor, that data that will be coming, the scanner status will be coming, the humidity will be coming. So it pretty much defines what data you are planning to send from your devices right here in the cloud. Once you do that, once your template, or once you have defined that okay, this is the attributes that I'll send, this is the pretty much key value pairs that you will send to the cloud. Once that's been done, you can start onboarding your devices. From a device onboarding standpoint, again, once you select your SDK, your SDK documentations will say how to onboard that device. But again, in this use case, let's take as an example that this is a Pi gateway that we have planned to use in this particular solution, or any other gateway device that you're planning to use in this particular application. One of the key things that we provide is a simulation. So depending on what attributes this particular gateway is sending, you'll be able to simulate it throughout for all your different attributes. So again, this template just has one RSSI into it. But if you have like 10 different attributes that you're sending to the cloud, then this page will show you 10 different attributes that you can configure from a simulation standpoint. And you can also mention that, okay, what time interval in seconds you want to simulate. So if you want to simulate every second, you can just send one, or if you simulate every 10 seconds, that's something that you will, and I believe that's the default. So you can simulate things every 10 seconds. You also have duration. So how long do you need simulation for? Depending on, if you are building some dashboards, you might need some data to test for say 10 minutes or 20 minutes or 30 minutes. if you want to use that data sets to generate AI, you can run simulation longer in that case, and then use the data that has been created by simulators to create some AI algorithms on top of it. But again, you also have duration. So going back, if your devices are not connected yet to the platform in real, you also have time. Then you can directly, use the simulation that we provide.
Vivu, I don't know if you can hear me. Can you hear me?
And start realizing what the value. Yeah.
You're cutting out a little bit. I'm thinking if you turn off your video, we might be able to not have that cutting out. So if you could do that, we might be able to hear you a little bit better.
Sure.
Okay, thank you.
Thanks for interrupting.
Yep, no
Yeah, this makes more sense now. So with regards to the gateway, like once your device is connected to the platform, as I said, you can either use simulations to send data or to see data on the cloud, or once your device actually connects using that particular template, you will be able to see all of these different properties of that particular device. So you can see what's the latest value that your device is sending. You can see the live data, and again, this is something that you can see what your device is generating. And then of course, if the data is not pretty good or if it's not correct, then you can go back to your device and change data. But this is a real-time view of your device, how it is. You can also execute commands, meaning that if your device or if your SDK or your firmware allows you to run commands on the device, say if something happens and you want to switch on an LED light, or if something happens, you need to capture an image using the image sensor that you might be having. So all of that thing you can very well easily do from the platform itself. You can configure different commands in the command sections right over here, and then that particular command could be, again, everything works on a name value pair. So you can say,
Are you sharing your screen right now?
I am.
All we can see is a simulator gateway and it's frozen. So I'm wondering maybe if you stop sharing and reshare, if that will help unfreeze it.
Sure. Can you see the command screen?
Yes, now I can see your mouse moving and everything. So I think we're good again.
All right, so we were here in the command screen. So in the command screen, you can define, your different commands, saying that, okay, as I explained, if you want to capture an image, you can very well do right from here. Write a command sending, or you can create a command over here, and then you can say that, okay, the key value of the command would be image, and the value would be, YN, something like that. And once you execute that particular command for that particular device, you will be able to capture or run that thing in your specific device that you have connected. So going back to the gateway example, you will see different commands that you can run. You can see your different train properties that you can run for that particular device. You can see all your notifications that got executed via the device, and notification is again specifically if you created any rules, what those rules execution are. That is something that you can see. I'll just show you the rules in about a minute. You can see your diagnostic data. Again, if you're sending any diagnostic data to the device, you can all see over here. So again, say if you're connected, you're disconnected, and any diagnostic information that you're sending to the platform can be seen in this particular section. And then, of course, you can see your historical data. You can run your historical data query depending on different date ranges, and you can see the graph view of it. So this is in terms what you can see from your devices. I'll go quickly to the rules section in the device. So let's pick one specific device, and I'll show you what kind of rules you can create on that particular device. So these are all the rules that are already pre-built for certain purposes. But let's say if you want to create a new rule, you can define what your template is. In this case, you'll have your own template name over here. You can define what's your severity level of that rule. So again, if it's a major, minor, warning, and the reasons to do the severity is how your rule behave when actually it's been applied to the field. You can select your attributes. What attributes? I'll just quickly select a template, and in this particular template, I'll select that, okay, the attribute is accelerometer, and the XYZ axis comes over here, and you will say, okay, if X axis does something. So if x axis is equal to a specific value, or if x, y, and z is all equal to specific values, then your rule will get triggered. When you trigger your rule, you will be able to specify, okay, what you want to do. Do you want to send a command back to your device, saying that, okay, if an accelerometer or if something happens, then probably take an image. If it's a normal temperature sensor rule, or if it's a geosense rule, so if you are defining your geo parameters of lat long, if something happens, then run a command, or run or send an email or send a push notification back. You can use webhooks to integrate your existing applications into it. So pretty much from a rule execution standpoint, you can determine what rule you want to create, and then what activity or what actions you want to do on top of that particular rule. Quickly, we also have firmware updates mechanism, so you can do you can create a firmware for that particular device, and then once you create a firmware, you can do OTA updates, sending that, okay, you can select what your device is, you can select what versions of software you are having, and then from there you can determine if you want an OTA on at a specific time, or you can also say that, okay, you want to send the OTA right now, so you can do an force update, and you can just update those devices with the newer firmware that you might have created. So you can create firmware updates and sends OTA updates to the devices right from here. Well, again, we are top of the hour here. We have good support that we are providing on our discussion pages. So if anything comes up, feel free to talk about those things in the discussions, and our architects will be able to help in that section. Majorly, follow the device SDK's processes. Once you decide what device SDK you want to use, just go in that device SDK, and from there you'll have lots of examples that you can use. You'll have lots of more code base that we are sharing in terms of examples or in terms of APIs. You can directly use it from here, and again, if anything comes up, feel free to put a discussion chat in the discussion place of Edge Impulse of ElephantEdge, and we'll be able to help you from there. I'll give it back to you guys.
Great. Thanks, Vibhu. We do have a few questions left, I think, that we didn't get to, so we'll go through those real quick, and then we appreciate you all sticking around for a few extra minutes, but if you do have to leave, we understand, and we want to thank you for joining us. So let's see, we've got about 4 questions yet that are waiting. So how do you evaluate machine learning models if the tracking dashboard isn't working? So we don't have a dashboard because we're focused on building the model, or we're combining multiple machine learning separate for audio, motion, GPS, etc.
Yeah, I understand the question. I think it's important if you are not using the dashboarding, or if you are not using any dashboarding, I think it's important to describe how that would work. So I think in any application, I think it's good to complete the whole use case, as we say. So imagine how this would be used, or your part of your application would be used in the total use case, meaning a collar being deployed on an elephant to protect it, and this involves also, of course, some kind of dashboarding or alerting, or some kind of feedback from the caller to park management or community. So I think if you are not going to make the dashboard, it's good to describe how that would look, or how you would use that.
Great, thanks, Tim. How do I connect NRF52840DK with either Edge Impulse or Avnet IoTConnect?
So with regards to Avnet IoTConnect, we provide the C SDK that you can very well use. It's been tested on a couple of the frameworks and couple of models over there. If you need more help, feel free to reach out to the discussion portal, and we'll be able to provide you help with the NRF 52840. But again, see the C SDK, see those documents, and hopefully that would be a straightforward thing.
Great, thanks. Can we use multiple notifications at once in IoTConnect? Does that affect processing time?
No, it won't affect processing time. You can create multiple notifications, and you can, with all those notifications, it will be all, executed parallelly. So there might not be much of any of an effect in the processing time at all.
Great. And the last one is, within the ElephantEdge project, are you mainly looking for coding more efficient ways of collecting data that's already being collected, or is it okay to hand in potentially less effective code with new data types to collect?
Well, I think it's very interesting to understand what kind of new ways you could bring into this topic. So I certainly would try to describe what you're trying to do and try to use any of the tools that are provided. So again, it's more about using your ideas and expressing them in a way that we can evaluate them, and I think then it's fine. Because there are so many ways we can attack this contest, and I think it's fine.
All right, great. I think that's all we had for questions. Thank you so much, everyone, for joining us today. Tim, Zach, Vibhu, thank you. It was really interesting learning about what you guys are working on and this initiative. So I did post some links in the chat earlier for all of you to go check out the contest and the challenge. And again, there are discussion forums there, so you can use those as well to ask any questions that you have after this. And we appreciate you joining us today.
And there will be another webinar soon, so it will be more about the hardware actually. So
yeah, and we should be posting that in the next week or so. So that information will be coming to you, so you can start registering for that as well. And we'll learn all about the hardware, and Tim will be joining us for that one as well. So.
Thank you.
All right, thank you so much, everyone. We hope you have a great rest of your day, and thanks for joining.
Thank you. Bye-bye.
Bye.